Alright, in this Algebra 1 video, Chapter 1, Lesson 5, we're going to talk about equations. Our objective is, as the student, I can solve multi-step equations with one or two variables because I will apply what I have learned about inverse operations and isolating variables, such as when solving for them. Now remember, an inverse operation is a fancy word for an operation that will undo another operation. It's like the opposite, essentially like adding and subtracting undo each other, multiplying and dividing, squaring and square rooting, although I don't know if we've mentioned that just yet. So different operations that undo each other, that's what we're talking about here. So we're going to solve equations regardless of what's given, or we're just going to reorganize them. We are going to start with some quick vocabulary words first. Alright, so two quick vocabulary words: an algebraic expression and equation. An algebraic expression is simply a math statement, and it's not going to have an equal sign. So an example of an algebraic expression would be something like 3x minus 9. There's no equal sign, there's no equality we're talking about, there's no left side equal to the right side, none of that. It's just an expression to where we can, if we are given a value to substitute in for x, we can do it, and we'll be able to evaluate it. And remember, to evaluate it means to find the value. What is it equal, like the actual number? And so as of now, there's nothing we can do with this until we are given more information. Now, an equation, on the other hand, is the same thing as above, but it's going to have an equal sign. So an example of that would be 3x minus 9 equals, let's see, 12. So now, this way, we now would have an equation to where the left side is equal to the right side. So it's an equation. The word equation, equal sign, that's where it gets its name from. The left side is equal to the right side. So just want to make sure we understand the difference. So now examples like this, you're not necessarily needing to even solve for the letter, because you'll notice P is already by itself. It's on the right side. It's already on the right side by itself. All you've got to do is isolate. I'm sorry, it's already isolated. All you got to do is solve for the other side, simplify the other side. But this brings me to a good point. Even if P was buried somewhere in there, you essentially need to think of it like this. In order to solve for P, you have to simplify both sides of the equal sign, meaning everything we've been talking about the properties of like distributive property or just simplifying and getting rid of parentheses and stuff. You would normally, that would be your first step for more complex equations. Simplify both sides as much as you can, and then start isolating your variable. So for questions like this, just go through the order of operations. So feel free to give this one a shot, press pause, and then hit play, see how you did. And then solve it all the way down. So we're going to talk about a special situation real fast. We're going to call it an identity. An identity is an equation that is true for any input in the variable. And essentially what it's going to mean is, I'm going to give you an example where when you solve it, it's essentially going to mean that everything is a solution, infinite solutions. I'm going to show you what I mean. So take a look at this example for this example problem. This is going to be, let's solve it and see what happens. Now, if you think you already know how to start simplifying each side using the order of operations, hit pause for a moment. See if you can simplify both sides fully. So make sure you're using the properties. Alright, so I see on the right side we can use the distributive property on that outside. And then on the left side, we got to divide this first, and then we can add 5. So I'm going to do both sides almost at the same time. Now, so I went ahead and just did the two things I said, the distributive property and then divide on the left side. Now, on the left side, notice, we're left with 5 plus 2 plus 3k. And if you're adding, we learned about the associative property of addition and even the commutative property. If all you're doing is adding, it doesn't matter what order you do it in or how it's grouped. So technically, we don't need those parentheses anymore. And that's why, because it's an addition problem. So at this point, we didn't even need them. Now, just go ahead and combine any like terms that you can, and then we're ready to continue. Let's combine like terms. You'll notice that the 5 and the 2 are like terms. That's going to give us 7. And then the plus 3k just drops down. Now on the right side, we've got 3k, but then we have like terms in those whole numbers, 96 minus 89. So go ahead and do that now. Do 96 minus 89. 96 minus 89 is 7. It's positive 7, so it's plus 7. Now, you'll notice at this step, look what we have on the left side. We have 7 plus 3k equals 3k plus 7. And in other words, hey, that's the symmetric property, where they literally just kind of flip the order of everything. And technically, we can even say that's kind of like the commutative properties. They change the order. But essentially, it's saying it's equal to itself. Now, if you're truly not sure, or maybe you didn't notice at this point that the two sides are equal to each other, you could keep going and solve. And if you did that, if you did keep going and solve, you would, for example, subtract 3k from both sides to move it to move that one to the other side, and then they would cancel over here, and you'd be left with on the right side 7, on the left side, oh, look at that, the 3k's also cancel on the left side, and you're left with just the 7. So on the left side you have 7, on the right side you have 7. Well, hey, that's a true statement, meaning all of your variables canceled and you're left with a true statement. If that ever happens, if all of your variables cancel and you're left with a true statement, that means there are an infinite number of solutions. That means any number that you plug in for k will give you a true statement. A million, negative million, 7.5, negative 7.5. If you plug it in for both k's and then do the order of operations correctly, you'll be left with a true statement. Now, if you didn't, like I said, if you didn't notice as of this step right here that the two sides were equal to each other and kept going, like I said, those two variables would cancel out. So just tell yourself that's your clue. If both of your variables cancel out and you're left with a true statement, that means you have infinite solutions. That means any number is a solution. And then vice versa, if your two variables cancel out and if you're ever left with a false statement, first thing is make sure you double check your work, but then technically that means you have no solution. That means nothing you plug in will equal, but that's not an identity. That just is another special situation. Make sure you copy this example down, please. A quick thought I want to make sure I add is not only does this problem have infinite solutions, everything is a solution, you could write your answer in the form of saying all real numbers. You could say that's your solution, all real numbers. And remember, all real numbers means every number in the real number system. Everything is a solution. That's the actual proper way of describing when you have infinite solutions. You say all real numbers, I'm done. So now let's do a situation when it was the opposite. Let's do an example of that. All right, let's take a look at this problem. And just like last time, take a moment to use the order of operations and the distributive property, it would seem. Simplify, not distributive property there, that's division in there. And go ahead and simplify everything as far as you can. And remember, parentheses and exponents come first. So on the left side, 2 cubed, 2 to the third power equals 8. So then 8 minus 5 gives us 3. So we went ahead and put that 3 there, so we didn't have to have 2 lines for that. And then on the right side, 5 minus 2 is 3. 10 times 3 is 30. And then continuing on the right side, so you have 30, and then plus d, and d times 12 divided by 6. You got to do 12 divided by 6 first, that's 2, so we have d times 2. So now d times 2, that's just otherwise known as 2d. So I'm just going to write that as 2d. Now we're ready to continue solving. So to continue from here, we got to subtract 2d from both sides. That's how we get rid of plus 2d and move it to the other side. Minus 2d, cancel on the right side. Now on the right side, we're left with just 30. On the left side, oh hey, look at that. Those 2d's cancel out as well. So all the 2d's are gone. Now on the left side, we're left with 3. So we're left with 3 equals 30. So in other words, our variables canceled out, and we're left with a false statement. This is not true. This will never be true. And so this means there is no solution to this question. And so if you worry you got that on accident, then maybe double check your work. Make sure that both of these d's were supposed to be 2d's, because that's the only way they'll cancel out is if they're the same, essentially the same magnitude. So if as long as they're both supposed to be the same, you're definitely good to go. And over here it's definitely 2 times d is 2d, and over here it's definitely 2d. So it definitely checks out. So keep that in mind when you're working on these questions. If you think you made a mistake, go ahead and double check. But in this case, that means there's no solution. So to this question, our answer would be no solution. That's what we would say. But we have to be able to justify and explain why. Also, I want to point out, that if you think you need more help with solving equations that have variables on both sides, the same variable on both sides, we did that really in depth last year. Some of you might remember the technique I made up called the Newton chicken method. It kind of helped you prioritize how to start those questions and the most efficient way to start solving them when solving equations with variables on both sides. So I'll put a link to that video in the description of this one. Feel free to check that out if you want to remind yourself how, because that was if you want to become an expert really fast at solving equations with variables on both sides. That'll have the main priority. But that technique will take place after you simplify both sides of your equation, meaning get rid of your parentheses as many as you can. Then that method totally kicks in and it's super effective and efficient. Now, I want to talk to you about 2 quick terms that you're going to see in your assignments a little bit. There are things called replacement sets and solution sets. Now, a replacement set, they're going to be inside of these brackets. These are called brackets right here. The replacement sets are essentially, they'll give you a list of numbers that they want you to check to see if there are solutions. And you're essentially going to plug it in and see how many of them, if any, will give you a true statement. Now, I agree that that's very time consuming. That's essentially kind of like guessing and checking for the solution. Our primary goal is going to be doing what we talked about, just simplifying and isolating variables and solving for them like we've always done since 7th grade. So, but that's going to be our main focus. So don't get too held back by the replacement sets. Like I said, our main focus is just how to solve equations like we've always done. Because guessing and checking is very inefficient. I just wanted you to know what it means when you see this these brackets like that. Now, solution sets will also be in the same format, though you can list your answers essentially inside those brackets as well, and then you can I think they're actually called braces technically, but whatever. And then you can list what numbers were your solutions. Like 3 was a solution, I don't know, 4 was a solution. Those were both making it true, but that most time we'll only have one solution for what we're doing in our class. But I wanted you to know what those terms meant. So perspective-wise, I just want you to focus on the techniques we've always learned about how to solve equations, meaning discover what value of the variable will make it a true statement. Doing what we've always done, getting x by itself. I'm just saying x because it's usually the letter. Getting x by itself by moving everything to the other side in the order of operations in reverse, by doing inverse operations. And for more details on this, I'm going to give you guys links to each of those equation solving videos that are really in depth we had from last year. So if you need some more explanation on how to solve equations, check those out. Other than that, we're done with this video. Go back and make sure you have anything to make sure you have it. If you missed anything, other than that, see you guys in class.